Okay, to finish up our video, or excuse me, our lesson, um, in regards to the chain rule, we're going to go ahead and find all the points on the graph of f of x equals the cube root of quantity x squared minus 1 squared, for which dy dx is equal to 0, or for which dy dx does not exist. Well, obviously, in order for us to find out where the derivative equals 0 or the derivative doesn't exist, we need the derivative first. So the first thing we're going to need to do is we're going to have to go ahead and rewrite this, because right now it's in the terms of roots, as a power function of some kind. So f of x is going to be equal to x squared minus 1. The squared part is the power, the cube part is the cube root, so it's going to be to the 2/3 power. Now we can take a chain rule derivative, so it's going to be f prime. The derivative of the outside piece is going to be the 2/3 x squared minus 1 to the negative 1/3 power, and then times the derivative of the composited piece, which is 2x. Okay, we're going to go ahead and rewrite this thing because we're going to need to find out where the derivative is equal to 0 or where it does not exist, so we need to have this in a simplified form. So it looks like the negative exponent is going to bring the x squared minus 1 to the bottom of the fraction with the 3. The 2 from the 2/3 is going to stay on top and get multiplied by the 2x. So we should end up with a 4x on top over 3 times x squared minus 1 to the 1/3 power. All right, so if I want to know that's our derivative. If I want to know when the derivative equals 0, the derivative is a fraction. So when the fraction equals 0 is when the numerator equals 0. So dy dx will equal 0 when the numerator equals 0. That's easy enough. That's 4x equals 0 dividing by 4. We know that x equals 0. So that's when the derivative equals 0. In order for the derivative to be non-existent or does not exist, it's where it's undefined. So it's going to be when the denominator equals 0. So dy dx is non-existent, does not exist, is when 3 times quantity x squared minus 1 to the 1/3 power equals 0. The nice thing is the right side of this is 0. Dividing both sides by 3 still gets 0. Raising both sides to the 3rd power to get rid of the 1/3 power still makes both sides 0. So really, it's when x squared minus 1 equals 0, which means that x is going to equal positive or negative 1. You could factor that to x plus 1, x minus 1, solve it that way. Or you could add 1 to the right side, taking the square root on both sides would give you the x equals plus or minus 1. So there you have it. All right. There's going to be certain times when they're going to give you values, and instead of giving you a function, they're still going to want you to take the derivative of different kinds of things, composites, products, quotients, all this other stuff. Little bit of a typo here. So suppose that w equals u of v. It should actually be u of v. It should look like that. Now, I'm not sure why there's a big O there. And it gives us all these different values. U of 0 equals 1, v of 0 equals 2, u prime at 0, u prime at 2, v prime at 0, and all this and so on. We want to find when w prime of 0 is. So if we want to find what w prime of 0 is, the first thing we need to find is w prime of x. So w prime, or w of x, is defined to be u of v, which we could write like this. Okay, it's probably an easier way to see it. Therefore, w prime is going to be the derivative of the outside piece, which in this case is our u, times the inside piece, times the derivative of our inside piece. And now if I want to find w prime at 0, I'm simply going to replace all the x's with zeros and figure out the values. So I'm going to have w prime at 0 equals u prime of v of 0 times v prime of 0. Well, now I can actually look up at my values and start replacing these values. So you got to work your way inside out here. So v of 0, according to this, is 2. So that goes there. I got to take u prime of that and v prime of 0. So u prime of 2 is given to us up here. That's 4. V prime of 0 is 5. So according to this, w prime of 0 is 20. Okay, and we did not necessarily need to use all the pieces up there, but they were given to us. So just know that they might not give you, or they're going to give you everything you need, but they might give you more than you need too. So, okay, so that is the derivative given a bunch of values using the chain rule. Okay, might have a chart. Very common. This was kind of weird. So f of x, this capital F of x, is the composite of little f of x with itself. And we want to find capital F prime of 2. So again, in order to find capital F prime of 2, the first thing I need is capital F prime of x. Well, it is little f of x. So it's the derivative of the outside, which is f prime of f of x, times the derivative of the inside, which is f prime of x. And then since I want to find capital F prime of 2, again, replace the x's with 2's, and we'll simplify. So f prime of f of 2 times f prime of 2. So now let's go to the chart here and figure this out. If I want f of 2, when x is 2, f of 2 is 1. So that's going to go there. So I'll do f prime of 1 times f prime of 2. Here's f prime, there's 2. So f prime of 2 is 5. And then I've got f prime of 1 here to deal with. And f prime of 1 is 4. That's kind of ironic. Again, I get 20. That's just coincidence. Just happened to be the numbers worked out the same. G will not work out the same way. All right, so we're going to do g of x the same way. I'm probably going to have to scroll up and down here. Let's see if I can do this or not without scrolling. So we need g prime of x, which is g prime, little g prime, of g of x times little g prime of x. And I want this at 3. So g prime at 3 is g prime of g of 3 times g prime of 3. Let's do this in red so I don't get it confused with all those green things up there. So g of 3, there's g, there's 3, so that's 2. So g prime of 2 times g prime of 3. So g prime of 2 is 7. And g prime of 3 is 9. So we get that g, capital G prime of 3 is 63. All right. Different table here. A little bit different on this one. Whoops. Okay. There is some vocabulary in this one that's really key here. It says, if g of x is f of x again, use the table to estimate. That is a major key in this. Estimate. Which means we are not going to be able to find the exact value, but we should be able to come up with a pretty good approximation. We want to find the value of g prime of 1. So again, we need to start off with the idea that if g of x is the function f of x, we want g prime first, which will be f prime of f of x times f prime of x. Okay, what you should notice from the table is what we are given is we're given function values. We are not given derivative values at all. So when I go to find g prime of, what is it, 1? G prime of 1. It's f prime of f of 1 times f prime of 1. The only thing I can actually find is f of 1. This I can actually do. F of 1, here's my function when x is 1, so the value is 2. So what I can do is I can do f prime of 2 times f prime of 1. This is where the estimation comes in. Remember that what we're trying to find when we find primes or derivatives is slopes. So f prime of 2 is going to be the slope when x is 2. Well, we don't have the function, we don't have the slope values anywhere. But what we do have is we have some values that are up around there. So if I want to find the approximate slope at 2, well, that means what I can do, let's see, here's when x is 2 right here. I can take those two x and y values, figure out what the slopes are between those, and then average them. Because if you think about it, this is an x and a y, x and a y. So I can do a y2 minus y1 over x2 minus x1. Then I can do it again using these two and this one. So let's see what we get here for that. So f prime of 2, I'm just going to put this up here. We're going to have to average these. So the first one is going to be 3.1 minus 2.4 over 2 minus 1.5. So what's 3.1 minus 2.4? It's 0.7 over 0.5, multiplying top and bottom by 10. That gives me 7/5. Okay, that's one side. Now if I approximate the other side, that's going to be 4.4 minus 3.1 over 2.5 minus 2. 4.4 minus 3.1 is 1.3 over 0.5. Again, moving the decimal place one place to the right gives me 13/5. So my f prime of 2 is approximately the average of those two things. So add them up, divide by 2. Or take the average between 7 and 13, which is 10. So 10/5 is the average, which is 2. So there's my f prime of 2, approximately. These are approximates. Got to do the same thing. Do this one in blue. X is 1, because I need f prime of 1. So I'm going to use these points right there. Have to scroll down a little bit on this one, I think. So f prime of 1, again, these are approximates. Using the first set of points is going to be 2 minus 1.8 over 1 minus 0.5. So 2 minus 1.8 is 0.2 over 0.5. That's 2/5. Okay, the other f prime of 1 approximation, using the second point, is 2.4 minus 2 over 1.5 minus 1. So we get 0.4 over 0.5, which is 4/5. Okay, that one's an easy one to average. What's in between 2/5 and 4/5 is 3/5. So the approximate value of g prime of 1 here is 2 times 3/5, which is 6/5. That is your approximate derivative of g of 1. G prime of 1, excuse me. All right, so approximate differentiation, there's an example of that. All right, last one. Okay, we've kind of dealt with this already in the fact that we did a triple chain rule with trig functions, a little bit easier with trig functions, but this isn't that hard. It's just tedious to write it out. So r of x is f of g of h of x. And then they give us a whole bunch of values up here. We want to find r prime of 1, so again, to find r prime, we need to find r prime of x first, which is going to be the derivative of the outside piece times the inside. Keeping all the parentheses straight here is probably the hardest part. 1, 2, 3, 1, 2, 3, that looks right. Times the derivative of the next inside piece, which is g prime of h of x. and then times the derivative of the last inside piece, which is h prime of x. So again, just keeping everything straight is probably the hardest part there. So r prime of 1, replacing all the x's with 1s. Whoops. Replace all the x's. Whoops, come on. Replace all the x's with 1s. And keep the parentheses straight. All right, let's start replacing values with what we can. H of 1 we can do. We have h of 1 up there. That's 2. H of 1 once again is 2. H prime of 1, that's that one, that's 4. Whew. Lots of parentheses to keep straight here. Now we can do g of 2, that's 3. G prime of 2 is 5. And I've still got that 4 on the outside, so then don't forget that that's still an f prime there. And then f prime of 3 is 6. It just so happened we actually used everything up on the top. So we get 6 times 5 times 4, which is going to be 30 times 4, 120. So that is r prime of 1. All right, now you guys should have everything that you need to be able to finish up and take the notes and finish up your WebAssign. Kept it under 17 minutes, a little longer than I wanted to, but not bad.